guys.
That's it.
And that's it. Yeah. All right, so here we go. So we got 1/2 to the x.
Yeah, we already did this, didn't we?
No. Pretty sure you did not do this. Thank you.
We're still doing
Was that for me?
No, we didn't.
All right. So
What
the
did you get for
first thing that you can
Christmas?
possibly do with this is first simplify. Is there anything that I can simplify?
Can't you just type this in your calculator?
No, not yet.
Yeah,
But
you
you
can
can type
simplify.
64 to the 1/2 in your calculator, which is basically the same as the square root of 64. Okay.
You could do 1/2 of the x in the graph.
Yeah, but x is so many different.
So, anyways, what we're gonna do next is when we have an exponential equation and you're solving it, the easiest way, in my opinion, is to convert it into a logarithmic equation. Okay, so what is the logarithmic form of this?
8.
The log of base
Log base
1/2
8.
of 8 is equal to x. So now, if you type that into your calculator, what is the log of base 1/2 of 8?
16.
No.
Why not? Oh, never mind.
Anybody want to type this in? -3. So you good there?
that one example down.
That's one example down.
How many examples do I have?
I have 8
Wait,
examples
dude.
total.
I gotta write all that.
8? Say 8.
I said 8.
Will you scroll
Yeah,
back
you
up?
did. Well, last year. You did.
Scroll back up a little bit.
Oh, not yet. Kind of. It's basically taking everything you have learned and kind of using it together. It's all there. That's
I
it.
gotta write what it's called.
Okay.
28.
All right, we ready? Okay, so on example 2, I have x's in 2 separate exponents. Okay, I cannot condense one side versus the other side. You guys need to close your tablets and quit playing whatever game you got going.
Yeah, guys.
Both of you. Okay, so what I'm going to do here is I'm going to manipulate the bases so they have the same base. So if I look at the two bases, I have a 16 and I have a 4. Can I manipulate one of those two so it becomes the same base?
4 times that by 4.
Okay, so 16 is the same as 4 to the second power. So this is what I can do here. I can rewrite 16 as 4 squared. Okay, then I have an exponent to an exponent on the left-hand side. If I have squared 2 and x plus 3, what do I do with those two exponents? Not add, multiply. So I'm going to multiply.
Why is that 7? Should be 6. 4x plus 7 should be.
No, that's a 7. That's
No, the original equation,
it's a 7.
Okay. Sorry, I thought you were simplifying that 4 squared.
You know what counting is?
Okay, so if I multiply 2 to the x plus 3, shh, guys, you need to stop talking and you need to focus. Okay, I'm going to get a new exponent of 2x plus 6 there. Okay, so now when I have the same bases on both sides, what can I do? You can cancel them out. They go away. So now I have 2x plus 6 is equal to 4x plus 7, and I have a linear equation that I can solve. Okay, so I can subtract this 2x, subtract the 7, doing 2 steps in 1. So what's 6 minus 7? -1. And what's 4x minus 2x? 2x. So if I now take that, my x value is -1/2. All right, example 3. Okay, this one is going to be a logarithmic equation. Okay, so if I have a logarithmic equation in its most simplest form, to solve it, I think the easiest thing to do is take it and convert it into exponential form. Okay, so if I convert this into exponential form, what is the base of this? What's a base of any natural log? E. So this is going to be e to the 6th is equal to x. If you type that in your calculator, what is e to the 6th? 403 point, what did you say? 43? 43. Because E is like 2.17. Or 2.718. Alright, number 4.
We're halfway there.
We're halfway there.
How many examples?
Alright, so I said on the previous example, if I condense it into its most simplest form, I can convert it to exponential. So on this example, I can start by getting rid of the 4 by doing what? Subtracting it. Okay, so what's 16 minus 4? 12. Okay, and I can also get rid of the negative 3 that's in front. How would I get rid of that? You could, but it's going to get more messy that way. It is going to be easier, yeah, to divide it to the other side and create less numbers. Because 12 divided by negative 3 is negative 4. So now I can convert it into exponential form. What is the base of this? 10. So it's going to be 10 to the negative 4th power is equal to 5x. What is 10 to the negative 4th power as a decimal?
1 and 0.
Yes, so 0.0001. I'm going to keep it as decimal form. And then divide that by 5 is 0.00002. Not too bad?
Oh.
Okay, ready for example 5. Okay. Log base 12 of the quantity of x plus 3 is equal to the log of base 12 of x plus the log base 12 of 4. Okay, so this particular equation has a whole bunch of logs in it. The first thing I want to do is condense them. On the right-hand side, if I have a plus in between two logs, what do I do with the values afterwards? Okay, so that's a property. I'm going to multiply the x and the 4 together, so can we just all agree that's going to be 4x? Okay, so now when I have a log of base 12 on both sides, what can I do? Cancel them out. Okay, so now I am simply left with x plus 3 is equal to 4x, and I have a linear equation to solve. So if I subtract the x, what is my value of x? 1. So x equals 1. You there? Cruising. Number 6. This is the best example. No, not this one. The next one is 6. 6 is good. So e to the 2 plus 3x is equal to 12. Okay, this is in exponential form. It is in its most condensed exponential form, so what should I do? No. Convert it. How do I solve? Convert it into a log. So good. So since I have a base of e, I can write it as ln. So you wouldn't say, there you go. Good. Okay. So throw that in your calculator. What is the natural log of 12? 2.48, you say?
Yeah.
Okay, and then we subtract 2, so how about 0.48 is equal to 3x What's 0.48 divided by 3? 6.25. 0.62. That's not right at all, isn't it? So, how about, what did you say, 0.6 what? 0.16. There we go.
Guess how we'll know?
What?
Class plan.
Class clown. Nice.